understand how to set that up. So frequency, you can either set a start and a stop range, or you can set by center frequency. Okay? Now, where's the, I think it's the sweep. So I'm not going to go through all that again. You understand what I did there, right?
Yep.
So if you change something, you put in a new number and then you enter it, and that's it. Now, let's go look at the sweep. So I want to get to the points. Let me figure out how we get to the point setting, because that might be useful for you to be able to change the number of points. Scale and amplitude, that's related to where you want to position this line. So you could go down to, say, 10 dB per division, 5 dB, 1 dB per division for more accuracy. And you can also set the reference plane. So where that reference, you can move it up and down depending on where you want that to be. So that's the reference line. It's currently set at 0 dB. The scale is at 10 dB, so that's 10 dB per division. So you can see 0, minus 10, minus 20, minus 30, minus 40. You can set that up, as I say, to minus 5 if you wanted to, or even 1 dB. Let's see if it'll do 1 dB precision. Yes, so you can get 1 dB per division on this, which I'd expect because it is a professional piece of kit. It's not like the Nano VNA. So let's put that back. It's also got auto scale, so that'll probably automatically set it at a particular value. It's set it to 5 dB in this case. It's changed the reference level, so I'm going to put it back to 0, and I'm going to set the scale back to 10, and we're right back where we started. Okay? So you can use the auto scales as well. And you've got this reference position, so you can alter. In fact, most engineers in industry, we tend to have it 10 dB below the maximum line there. So I think it's 9 is the default. So, oh, I've gone the wrong way. Maybe it's minus 9.
Click perfect position.
I've got to do it. Hold on. Let me go back. Minus 9. Is that right? Is it gone? No, it's gone too far. So it's gone to 0, so maybe it's 1. Depends on the instrument. 1. Yeah, there you go. Okay. So what you're seeing now is you can actually see the noise floor of the VNA. That's the noise floor there.
Oh, that's really low.
Yeah. Okay, so that's typically how we set it up for industry measurements. If you're using an amplifier, so that's fine for filters, anything that's got loss. But if you're using it for amplifiers which have gain, that means you're going to be positive of that line, and you should set it probably back to 5 to see where things are. Okay, so that'll set it back to a midpoint. So 5. All different instruments. What was I on?
Response
Sweep.
time.
Is it sweep? Oh, I'm stuck in this now. I've got to follow it through now.
Normalization.
Let me go back to this. So that's for doing the cal. Do the cal. So this is a through cal, S21. You can also do it for S12, which is looking the other way. So that would, this would become the source if you're using it for S12 measurement. At the moment it's S21, so it's going between these two parts, from this to this. So let's do the normalization measure, and that'll get me out of that menu. Ish. Right, there you go. And then I think it was, yeah, this is the one. So we can set that back to 5, for example, if you don't want to see the noise floor. There you go. So the noise floor is below that reference line now. So what else can I show you on here? Still trying to find out where the number of points can be set.
Maybe system.
And keep going. You can also store traces as well. You can store a trace. Maybe it is under system. You might be right. System configuration. No, it's not that. It's not that.
Scale or amp, something like that.
Scale we've already looked at. More. Hold on. No, it's not that one. Well, we've got to find this.
Frequency or distribution.
Frequency. There's no other menu in there though, that's the trouble.
Well, what about?
There's no other menu, so let me get rid of that hold. That's so. Did you see the red hold?
Yeah.
So it's resumed its sweep now, it's sweeping. So
okay.
let's go back to, because I'll show you something now. Go back to amplitude.
Oh, what about measure
Let's
setup?
go take that to 1. Yeah, that might be measure setup.
Yeah.
You see it's updating now. You can see the
Yes.
noise floor changing. It's because the hold was on, so just watch for
Oh.
that. What button did we say we were going to press?
Measure setup.
More advanced. No, it's not in
The 4th button.
measure setup. Calibration settings, transfer type. It's not in there. Ah,
Oh, there we go. Resolution.
can we get to it?
201.
Yes.
Yeah, there we go.
Edit.
Can we just
So let's see if it goes to 401 and it accepts that. Yes.
Nice.
So what you'll see now is you'll see a higher granularity now in the noise floor. So let's just do that. You see that?
Oh.
Because you've got more data points. So if you want to increase your accuracy, your measurements, increase the number of points.
Got it.
Now this one, I'm trying to think what it'll go up to. Let's see how far we can go. Which was I in the right menu?
Yeah, settings.
Settings.
There we go.
Ah, there we go.
401,
Excellent.
change
So
it to 8.
Yeah, let's see if we can go up to 801.
Yeah, edit.
8. Oh, it's accepted it anyway. 801.
Nice.
Yes.
There we
Okay.
go.
So now, when we go back, you can see.
Oh, the sweep is slower.
Right, and that's exactly what I said to you. I said your sweep will go down. So it's a compromise between, if you're doing measurements on some system, do I want accuracy, in which case I've got to wait for the sweep updates, or do I want speed and just get a measurement? If you're wanting higher accuracy, you're going to have to wait for it because it takes time for it to do a full sweep. Okay? It's all right, I've got it. Are you following, William?
Yes, I mean, you're...
Have I explained it well? Have I explained it well enough? So, all right, we've still got a good cal there. But if you go down to scale now, if we take it to 1 dB, you can see that there's some weird little resonances there. Can you see that?
Yeah.
So it's not perfect when you go down to a 1 dB.
And is it due to the cable? Or?
Yes, you've got cable. In fact, you can start to see when you move, maybe not at these frequencies, but certainly at higher frequencies, just moving the cable will change the response because you're changing
the impedance.
Yes, inside here is a dielectric, and you've got the inner conductor. And as you bend this, and that's why you've got to be so careful with these cables, is as you bend them, you're changing the response. Particularly, you'll notice it more at higher frequencies. So at a few megahertz, you won't notice it. But when you go up to 6 gigahertz and you start flexing and bending things, you will see it. Now, I worked on filters and amplifiers up to 50 gigahertz, and you only had to breathe on those things for them to start moving around. They were horrible to work on. Slight modifications would make big changes if you weren't careful. So at the frequencies of operation for your stuff, you're not going to have any big issues. But you need to be conscious of the fact that it's not perfect. That's why we have to use the cal standards. Now, when you were doing 3360, why do you use the cal standards?
Because you want to...
I mean,
you want
have a base, you know, just
normalize it to the reference value.
Think about it. Why do you need
otherwise
to have
everything
calibration
will be
standards? Because you
haywire.
can't realize precisely an open circuit or a short circuit.
Because of the parasitics.
Because of the because of the RF, the nature of RF signals, you've got reflections, haven't you, with a short circuit?
Yeah.
So it's not a perfect short circuit. It's never perfect. And you're trying to do that calibration over a wide spectrum of frequencies, not just at one, but multiple. So that's why we need the cal standards. Okay, that's the rationale. That's why you're not using the simple ABCD based networks. But you did talk about that in your course, right? The different types of
the coupling,
4-port and 2-port networks.
Yes.
Okay.
Well, briefly.
Oh, it's a whole science. There's a book by a guy called Scanlon. It used to be a de facto text on the matter, and it was just on network theory. Network theory alone, it gets pretty sophisticated. So they used to teach it at a very detailed level, but now there doesn't seem to be time to do it. But when I studied it many years ago, Scanlon was the de facto book that we read and studied, and I think there were 2